Hey guys, welcome to Bar Z. My name's Stan, and there was a topic. I actually got an email over this. We've got a tool block here that we're building, and there needs to be a V groove in the middle. And the guy was asking, "Hey, I've got a V-shaped cutter, and I want to know how to center up on it. How do I make sure my V's are dead center?" Well, you don't even need a V-shaped cutter to do this. And I'm going to show you how to do it, and we're going to do it without even tilting the head of the milling machine. We've already drilled and tapped 2 holes. I got two 1032 holes here. They're all mapped out off a center, left, right, and then the proper distance in from here. But now all we need to do right now is get a center line on it. So I'm going to pull that tap out and just put a kind of a little scribe in there. I've got some little carbide points right here. I'm just going to chuck one of those up and create a scribe line right down the center using the DRO before I take it out of the before I take it out of the vise. So let's do that real quick. Pardon the back of my hand. And I've got a carbide point in there, and now we're going to drive the milling machine over to back to center. Just using the DRO, we're going to go back to our center line. Before we take it out of there, give yourselves a few seconds to stop and think what else needs to be done before I take this out of the vise. Taking something out of the vise is a commitment. All right, we're back on 0. We're just going to come down and just lightly touch and run our y-axis back and forth. And see, we created a very small scribe line. I'm actually going to make that a little deeper. I'm going to go another half thou on my quill. Just make that a little deeper. There we go. Just something we can see. So we've got a pretty nice little scribe line there that we can follow. And we already know that's center line of our part. So now we can take it out of the vise, and we're going to set up the vise for 45 degrees. You could tilt the head if you want to take the time to do it, but if you've got a 45 degree square, something small that fits in the vise, you can do that too. You need to be able to bolt your 45 degree angle into the vise, and I'll show you that here coming up. Okay, this is what we're going to use. Now these are some blocks that I made. They're hardened and ground tool steel, and they've just got a little slot in the bottom, and those use a 1032 screw. And you say, well, how are you going to bolt those into your vise jaws? You don't have any holes in your vise jaws. Well, the actual bolts are drilled and tapped on center there. And this little guy just goes in and it indexes right to the bed of the vise. And it'll go in there and it'll bolt in. You can bolt that turkey in right up against that, vise jaw. And if you need to use a second one, you can. You bolt it in right next to it. And look what you got there. Let me swing the camera over a little bit and you can see what you got. Alright. So these can be bolted in as so, or you can actually take this and flip it and bolt it in at a 90. You can bolt it in this way at a 90. They're pretty handy. I've used them an awful lot. When I made these, I didn't think I was going to use them that much, but we're going to use at least one, and then your parts are going to go in at a very accurate 45. We may use 2. We'll see how it works out. But as you're tightening your bolt, make sure that this stays down to the bed of your vise. Always tram the bed of your vise. If you're doing a lot of vise work, it doesn't hurt you to go ahead and indicate off of the actual vise bed. Make sure you're parallel to that. Okay, so let me get these installed, and we'll show you the rest of the setup. Okay, well, we've got our two angle blocks in there. I tapped them down, make sure they're tight to the bed, and you know, clean. Everything's clean. I got all the vise. I got this vise all clean, and our part here can just now come in. And two things are going to happen. First of all, we're holding it at an accurate 45. Second of all, we've got it on a backstop back here, so it's going to index the same way every time we drop it in. So we'd come in here, we would set up the very corner of the end mill to our scribe line. You know, as accurate as you can by eye. I know you're going to be a little bit off, but here's the kicker. We do a straight down feed and make a cut, and then we have to do after that is flip the block back in and leave the same down feed and come across again. And we're working the laws of averaging now, and this way, no matter how much down feed we give it, we're going to stay on center. We're going to stay on center with the tool block, and the V is going to stay center by center every single time, because like I say, you're working the laws of averaging just by flipping this block each time. And you know, these things took me 5 minutes to put in here. If I was trying to get my mill head at 45 degrees, I'd still be messing with it. But I don't know of any of these that are commercially made, you know, for a vise, but they're a wonderful thing to have, and highly recommended that you build them yourself. These are just made out of a 1/2 inch thick 01 tool steel, thrown in a hot shot, hardened, and then grind them up. And be very particular. This is tooling, so it needs to be as accurate as you can possibly make it. Okay, I've got a very sharp end mill. There's very little corner radius on that thing, so what I want to do now is pick up that scribe line there. And you're just going to do it with magnification and light and get it as close as you possibly can. I'm just fudging this thing over a few thousandths at a time. I'm starting to see a couple of chips, and it looks like I'm right in the groove there. Let me hit this with a light real quick. I'm probably going to blow you guys out. But I am right down in the groove there. So what we're going to do now, I'm going to zero my quill DRO, and I'm going to zero my x-axis. I was working it over there with the x-axis, and I'm going to move those equal by equal. So I'm going to bring my quill down 20 thousandths. And then I'm going to move my x-axis over 20 thousandths. Give it just a touch of oil on that leading edge. Everything's locked. I'm ready to cut. And now's a good time to double check your work. I'm doing a bozo check there. Okay, so that's the start of our V groove. We've got a point of reference on the Z-axis, which is the quill, and we've got a point of reference on the X-axis, which is the table, longitudinal X, and you just keep those steps going. And when you get to your final, I'll show you how to do that. Let me get this thing down to depth, and I'm not going to bore you with all the all the extra stuff, you know, all I'm doing, I'm taking a 20 thousandths bite at a time. Right now I'm bringing my quill down a total of 40 thousandths. And I'm going to move my table I'll move my table over a total of 40 thousandths. And, you know, all we're going to do is repeat that. All right, and you see our groove gets quite a bit bigger. I mean, we're moving 20 thousandths in each direction. And on the last step of the process is to flip this block. You know, if you've made any kind of mistakes or anything, when you flip it, that'll be evident. And the last operation, when you flip the block, that's going to get your V-groove dead center of the part, as well as the right depth, and you know, all things being equal. This is a part that's getting hardened and ground anyways, so I have to leave a grinding allowance on it. But let me get to the proper depth, and then I will show you the final equalizing of the center. Yep, I'm right where I want to be. Now all we have to do is center it up. Let me clean this vise and get ready to flip. We'll throw a tattletale on there real quick to know what side we're touching and what side we're not. All I'm going to do is put a Sharpie mark on each side of the flank to know where we're hitting and where we're not hitting. All right. So all we're going to do right now is just flip, and we're not changing our milling cutter at all. I'm going to flip that dude in there, make sure it's seated up against both V-blocks. And just run it through again and see where we hit. We're hitting on the wall on the left. And by all rights and reasons right now, our block should be equal. That V should be dead center and equal lengths both sides. We can flip it again and turn the wall. You can see I hit that one wall, took that Sharpie off of there, but I still got that Sharpie right there. And we can run back over that, and it should just kiss that one side. And you can see it's just barely pulling that Sharpie off of there. Just a light spring pass across there. And you can see it's just kissing that Sharpie. All right, so now we know we are center by center. that's it, boys. And that's an answer to your email, Todd, that you emailed me a little while ago. I'm going to send you a link to this video. But that's how you center up a V-groove on a block and keep it center and keep it 45. Okay, well, here's what the part's for. I got you back on the back of the surface plate looking at it. This is a headstock. This is a spring-loaded headstock right here for a tool. So that's a spring-loaded headstock with a V-notch already in it. And this is actually a tailstock, and they have to match. So what I've done is, you know, with just measuring the width of the V-groove, you can get it close, and then you take a center or something round or gauge pin, whatever, stick it in there, come across, make that sweep, come over here, and you make this sweep, and you get them equal. As you can see, I'm tall right now, and that's what I wanted to. That's what I want. I got about 30 thousandths to go, and this V-groove is going to actually get ground to match, and I might bring you back for that. You guys have all seen me grinding V-blocks and how to average the V-groove and get it on center and to a very specific depth. But maybe we'll repeat that process. So what we're doing here is sweep the top of that, get a measurement, sweep the top of this, get a measurement, and that tells us what we, you know, how much we need to take off. And there's a little math involved. You got to use the sine of 45 degrees to figure out your down feed on your wheel, you know, when you're doing your final grinding. But we need to match those within a couple tenths. This is a precision gear measuring machine, and the owner of it is missing the tailstock. So I am tasked with building that for him. So anyways, that's where we're at with it. That's the rough machining, and I always shoot to get my parts within 20 or 30 thousandths oversized in all directions, because we do know that we need to, we're going to build up a scale and parts move and everything else, so we need to leave enough room to grind it away. Let's finish this block up, and maybe I'll bring you back for the grinding. Again, thanks for watching.